All right. Good day, grade 10s. Absolute coldest day of the year. Chaos in our house. Don't even look behind you. I'll be in such trouble if you can see what's going on because of painting and everything's dumped in our room. All very hectic. Right. Let's get on with it. You're going to be needing this factorization involving complex numbers worksheet. Okay, worksheet for session 17, and coming through the snow today to get here and help you out, just like Odin, the god of war. We're very grateful to have Nao. I will introduce him to you later. Nao and Hannah and Pila, thank you for coming in. Right, so up to now you've only factorized in the set of rational numbers. Now you're going a bit further. I'll show you the difference between AP and core. And your first principle is a perfect square. Okay, a perfect square. Well, they're not really perfect squares. It's just something plus or minus another. Ignore that. Okay, right. So basically, your principle is this. Now we can have, if you had x squared minus a, let's just get straight into it. X squared minus a could be factorized to x minus root a, x plus root a. And what does factorizing mean? Remember, it means rewrite something as something times something. And what's got to happen when you times it back out? It's got to get back to where you started from. So x times x, x squared, plus root a x minus root a x disappears. Negative a, remember, root a times root a is equal to a, right? Okay. So x squared minus a factorizes to x minus root a, x plus root a. Then, okay, so your x squared plus a would factorize to x plus, I'll explain this now, root ai, x minus root ai. Okay, times it back out and check, okay, that you get back to x squared plus a. Well, x times x, if you times that back out, would be x squared. Those two would cancel out, and you'd be left with root a times root a. So positive root a times negative root a would be negative a, okay? And then I times I is I squared, and we know that I squared is equal to negative 1. Remember that? I squared is negative 1. Okay. So you're going to get x squared minus a times minus 1, which gives you x squared plus a. Okay, so it's working. So I'll go over that again. So if it's x squared minus something, you can factorize to x minus root a, x plus root a. If it's x squared plus a, okay, it will be x plus ai, x minus, x plus root ai, x minus root ai. Okay, so those are going to be your two basic principles. What has to happen when you times it back out, you should get back to where you started from. So I'm going to work you through the left-hand column of exercise 5, A, C, and we're going to start off with types like this. So we're going to do A, C, E, G, I, and K. Remember, try to do them yourself, and then come have a look at the memo. So x squared minus 5. Well, if you're factorizing in core, you wouldn't be able to. Okay, can't be factorized because we only factorize in the rational numbers in core. Okay, we don't say anything, factorize in rational numbers. Okay, but it's implicit in the core syllabus that we're only factorized in the rational numbers. So in core, you just simply say for x squared minus 5, you'd say can't be factorized. Okay, but in AP, okay, well, it's of this pattern, so we can factorize in the irrational numbers, and it'll be x minus root 5, x plus root 5. Okay. If you times it back out, you'd get x squared. Those cancel out. Root 5 times root 5 is 5. So there is your solution. X squared minus 5 factorizes to x minus root 5, x plus root 5. X squared minus 12 would be the same kind of logic. It would factorize to x minus root 12, x plus root 12. And ideally, it's implicit that everything we don't have to, should be in simplest third form. Okay, so you can cheat and use your calculator, but it's not that difficult. You're going to say x minus, well, I'm going to show you the step. Normally I wouldn't. that would be 4 times 3, 12. Remember, one has to be a perfect square, plus 4 times 3, okay, which will become x minus, well, the square root of 4 is 2. You can do them separately because it's times x plus 2 root 3. Okay, so there is your solution over here. Okay, it factorizes to x minus 2 root 3, x plus 2 root 3. Your textbook likes to do this. They like to solve the equation. This is alternate method for the same sum. They solve the equation, and they go x squared is equal to 12. Okay, so they let the equation be equal to 0, then they go solve that equation. So you're going to get x is equal to plus minus root 12. So x is equal to plus minus 3 times 4 becomes 2 root 3. And if 2 root 3 is an answer, it means x minus 2 root 3 is a factor. And so it's x plus 2 root 3. So it means if you times the two factors together, you'll get back where you started. So in other words, x squared minus 12 is going to factorize to x minus 2 root 3, x plus 2 root 3. So that's always an alternate solution. You go figure out the solutions. Okay, once you've got the solutions, okay, you work backwards to factorize. Okay. Right. And then x squared plus 5. Well, if it's a plus, we're going to have an I involved and a difference of squares. So it's going to be x plus root 5 I, x minus root 5 I. Okay, until you're confident, quickly go check it out. X times x is x squared. Those two are going to cancel. And then you're going to be left with minus, well, root 5 times root 5 is 5. And I times I is I squared. Okay, which is going to give you x squared. I squared is negative 1. So minus 5 times negative 1 is I squared, x squared plus 5. So x squared plus 5 factorizes to x plus root 5i, x minus root 5i. Okay, in your textbook, what they often do, if you look at the examples, they just go solve it, make the equation equal to 0, and they go, therefore, x squared is equal to minus 5, therefore, x is equal to plus minus, okay, square root of negative 5, which is x is equal to plus minus the square root of 5 times the square root of negative 1, which is I. Okay, so they get the solutions. So if x is equal to root 5i, or x is equal to minus root 5i, okay, this is just an alternate method. I prefer this, but okay, which means that x minus root 5i is a factor, and x plus root 5i is a factor, and which means that if I times them together, that x squared plus 5 will factorize into the product of those two things. So x minus root 5i, x plus root 5i. It's up to you which method you prefer, just doing the factorization straight out or by getting the answer and working backwards. With some questions, we are going to have to just work out the answer and then work backwards. There's no other real viable way of doing them. Okay. Right. Hope you've got that all down. Right, question 2. Again, the question is factorized in the complex number. For all of these questions, okay, I'll show you the solution in the reals. Okay, well, x squared plus 18 for core, you just say can't be factorized. Okay, can't be factorized. That says no, you can't read it. Okay, but in AP, okay, it's going to be x plus, you can factorize anything, root 18 I, x minus root 18i. Check. If you times it back out, you'd get x squared. Those would cancel out. Root 18 times root 18 is 18. I squared is, so you're going to get negative. If you times that out, you're going to get negative 18i squared, but I squared is negative 1, so you end up with plus 18. Right? You should always leave it in simplest third form. And root 18, remember, can be written as a product of 9 times 2, because 9 is a perfect square, which is going to give us the square root of 9, which is 3. So it's going to be 3 root 2. So this is going to factorize to x plus 3 root 2i times x minus 3 root 2i. Okay, and there is your answer. Okay. Oh, I haven't even asked my assistants to help us here. Right, so now, in the next one, 3x squared minus 6. Well, in core, how would you factorize that? you'd just take out a 3, and you'll be left with x squared minus 2. And that'll be your answer in core. You'd stop there. Okay. But in AP, we can go a bit further. And what is it going to be, Pila? Okay, well, it's going to be x minus root 2. You don't have to have an I here. If it's minus, there's no I. If it's plus, there's going to be an I. X minus root 2, x plus root 2. If you times that back out, you're going to get x squared minus 2. 3, thank you, Pila. It's going to be 3x minus root 2, x plus root 2. Okay, so that would be answer in AP. Hannah, in core, in grade 1, what did you do? Good, you took out a 2 and you're left with x squared plus 6. That'll be the answer in core. In AP, we can take it further. Seeing as there's a plus, a sum of two terms with a plus, you can always have an I involved. So what's it going to become? Good, it's going to be x plus root 6i, x minus root 6i. You're constantly using this principle that I times I is equal to I squared, which is negative 1. Okay, that's being used over and over again. Times this back, and you're using the constant idea that root a times root a is a. Those are your two key ideas when you're checking. Okay, root 6 times root 6 is 6. I times I is negative 1. Okay. So that's how you end up getting back to where you started. So there is your solution. Thank you so much, Hannah. Your input is greatly appreciated. Right. So those are ones of that type. Okay. Now you're just going to have trinomials. I should really have said. Trinomial. Okay, you can add that in. Trinomials. Okay. So they're all quadratics. The last ones we're working with were also quadratics. But now we're looking at trinomial, 3 terms, which can't be factorized in the rational numbers. Okay, where previously you're working with binomial quadratics. So the heading is quadratics, factorizing quadratics, which can't be factorized in the rational numbers. In other words, you're going to end up with surds, things like that. That's what I mean by surds, or imaginary numbers in your factorized solutions. So your first thing you're going to do in these questions is you're going to like this, the alternate method I showed you for the previous ones. You're going to solve, let the quadratic be equal to 0, and you're going to solve it using the quadratic formula. Okay, the quadratic formula being x is equal to negative b plus minus b squared minus 4ac all over 2a. Right, so you're going to solve using the quadratic formula. Once you've got your answers, you're going to use the principle that if x is equal to a and x is equal to b are solutions to a quadratic equation, okay, then the quadratic must factorize. Then the quadratic factorizes to, well, if x is equal to a, then x minus a, x minus b. Remember, minus doesn't mean you end up with a minus. It just means opposite. Minus a means the opposite sign of a. Minus b means the opposite sign of b. So it'll factorize to x minus a, x minus b. So you're going to get the answers, okay, and then kind of work backwards from there, okay. And to illustrate this, we're doing exercise 5, question M, and then one extra one. So first of all, exercise 5, question M, it says, question is factorized in complex. Okay, in the real, in core, you'd say can't be factorized. Can't be factorized, that's what you say in core. But in AP, so you try factorize, you see it can't be factorized. Okay, but look at the mark allocation. If it's for 5 marks, obviously you can. Right, so we're going to use a quadratic formula. So we know that A is 1, B is negative 2, and C is negative. And then we're going to use the formula minus B plus minus B squared minus 4AC over 2A. So you're going to get X is equal to, okay, you're going to let F of X, you're going to let the whole thing be equal to 0. Okay. You should really say that. The textbook I don't think does often. Let x squared minus 2x minus 2 be equal to 0. And in that case, x is going to be equal to minus b. So it's going to be minus minus 2 plus minus b squared minus 2 squared minus 4 times a is 1 times c is minus 2 over 2 times a, which is 2 times 1. So it's minus b plus minus minus 2 squared minus 4 times 1 times minus 2 over 2. So therefore, x is going to be equal to 2. So minus the square root of, well, minus 2 squared is 4, and then you're going to get 4 plus 8, which is 12. You can check that if you want. Yeah, all over 2. Okay. So you're going to get x is equal to 2 plus minus, well, 12 becomes 4 times 3. So remember, the square root of 12 is equal to the square root of 4 times the square root of 3, which is 2 root 3. So it's 2 plus or minus 2 root over 2. You're not cancelling. What you're really doing is this. You're saying x is equal to 2 over 2 plus minus 2 root 3 over 2. So in other words, your final solution is x is equal to 1 plus minus 2. The 2's cancel there. So it's 1 plus minus root 3. So there are your two solutions. So x is equal to 1 plus root 3 is a solution. Okay. So x is equal to 1 plus root 3 is a solution, or x is equal to 1 minus root 3. Okay. And if x is equal to 1 plus root 3 is a solution, okay, then x minus 1 minus root 3 is a factor. Okay. Is a factor, and x minus 1 plus is a factor. Okay, and in other words, the quadratic x squared minus 2x minus 2 could then be factorized as the product of its factors. That's what factorizing means. So it would factorize to x minus 1 minus root 3, x minus 1 plus root 3. Okay. X minus 1 minus root 3, x minus 1 plus 3, and there is your final answer. Okay, x squared minus 2x plus 2, how can it be written as a product of its factors if we work in the complex numbers? X minus 1 minus root 3, x minus 1 plus root 3, you've written it as a product of its factors. You must always check, have you rewritten it as something times something? Right, so based on that, now what you're going to do in this extra example, I said factorize x squared plus x plus 7. So now what's A? Good, 1, B is good, 1, C is 7. And then we're going to use a formula. So x is going to be minus 1 plus minus the square root of B squared, 1 squared, minus 4 times A is 1 times C is 7, all over 2A, which is 2 times 1. Okay. So therefore, x is equal to minus 1 plus minus, well, you get 1 minus 28, which is minus 27, all over 2. Okay, and you go solve it. We should have said let, in the beginning, x squared plus x plus 7 be equal to 0. That's how we should really have started the sum. Okay, so those would be the solutions. Remember, this means x is equal to minus 1 plus minus, well, negative 27, you can think of as being 9 times 3 times negative 1. Okay, all over 2. So you end up with x is equal to negative 1 plus minus square root 9 is 3 is the square root of 3, and the square root of negative I. So you get negative 1 plus minus 3 root 3i, all over 2. Hope we don't run out of space. So in other words, x is equal to negative 1 plus 3 root 3i over 2. X is equal to negative 1 plus 3 root 3i all over 2. Or x is equal to negative 1 minus 3 root 3i over 2. Okay. And I can think of it as negative a half plus 3 root 3 over 2. So in other words, x plus, okay, a half minus 3 root 3i over 2, okay, is a factor. Okay, I just moved everything to the other side. I split that up so that x is equal to negative a half plus 3 root 3 over 2 minus 3 root 3 over 2. Just when you move things, solutions across, okay, they change sign. So that's one factor. And here you're going to have x plus a half plus 3 root 3i over 2 is a factor. Okay? So in other words, this thing could be factorized. I'm just going to have to go over here. So x squared plus x plus 7 can be factorized to, well, there's your one factor, x plus a half minus 3 root x plus a half minus 3 root 3I over 2 times, here's your other factor, okay, x plus a half plus 3 root 3I over 2. Okay. You could also just write it as all over something. So you could have written it as x plus, you didn't have to split them up, x plus 1 minus 3 root 3I all over 2. That would have been acceptable. And x plus 1 plus 3 root 3I over 2. And those are a bit of a mission. Okay. I'm not a big fan of those type of factorizing questions. Okay. I mean, it's more a question you'd ask, I think, solve. But that comes up, so you've got to know how to do it. So there's your final answer. X squared plus x plus 7 factorizes to that whole nest over there. X plus 1 minus 3 root 3I over 2, x plus 1 plus 3 root 3I over 2. Okay, not a very pretty one, but done. Right. Page 4. Okay, Hannah. Right, in here it says factorizing the sum and difference of perfect cubes in complex numbers. So your method, you've done this in core, factorizing the sum and difference of perfect cubes, but you've only done it, you've stopped once you've got to your rational factors. So first you're going to factorize in reals, as in core maths, and then you're going to solve the quadratic equal to 0 using the quadratic formula and work backwards, kind of like exactly what we've been doing previously. Right. So go factorize this like you would in core. Go factorize x cubed plus 64. And Hannah, if I factorize x cubed plus 64, what do I do? Good. You take the cube root of those two terms, so it's x plus 4. Then your principle is you square the first term, which is x squared, times the two together and change the sign, so it becomes negative 4x. And then 4 squared is 16. So you get x plus 4 times x squared minus 4x plus 16. In core, that would be it. You're done. 4 marks. Okay. But in AP, we can factorize this a bit further. We can factorize that in the complex plane. So we're factorizing in complex numbers. In the real number system, we'd be done up to there. So what I do in the complex number system, I've got x squared. I'm going to solve the equation x squared minus 4x plus 16 is equal to 0. So we've got a is equal to 1, b is equal to negative 4, and c is equal to 16. This, by the way, is question O, right? So if I use the quadratic formula, I get x is equal to negative b, which is negative 4, plus minus the square root of b squared, which is negative 4 squared minus 4 times a is 1 times c is 16, all over 2 times 1, which is going to give us what? Pilar, you're going to get 4 plus minus. Let's just have a look. We're going to go 16, too tired to do this now, minus 4 times 16, which is going to be negative 48. Okay, 4 plus minus negative 48 all over 2a, which was 2 times 1, which is 2. Okay, just to show you, let's just check. If you go to the square root of negative 48, okay, I'm not in the complex number plane. Okay, there is a way I can change it into complex. You can go mode 1 complex and then go square root of negative 48 and it'll do it for you. Should have. Okay. I don't know what I'm doing wrong. Right, let's just let your calculator can in some way. But it's more fun to do it. But you can check the third, remember, root 40. That's okay. So you've got a calculator that can become 4 root 3. Okay, root 48 is 4 root 3. But remember, you don't really need a calculator. You can just think of it like this. X is equal to 4. Okay. Right. I hope this is still recording. It's got a little message. So x is equal to 4 plus minus. We end up with, well, root 48 you can think of as 16 times 3 times negative 1. Okay, all over 2. So therefore, x is going to be equal to, this is from the last sum. I'm going to go up here. So I get x is equal to 4 plus minus, the square root of 16 is 4, as your calculator said. Root 3, square root of negative 1 is I. 4 plus 4 root 3i all over 2. If you divide everything by 2, you get therefore x is equal to 2 plus minus 4 divided by 2 is 2 root 3i. So your solutions are x is equal to 2 plus 2 root 3i, or x is equal to 2 minus 2 root 3i. So if the question had been solved for x, you'd be done at this point. Okay, it would be 2 plus 3 root I, 2 minus 3 root I. They're your three solutions. Okay, it would be x is equal to negative 4, x is equal to 2 plus root 3i, x is equal to 2 minus 2 root 3i. But the question didn't say solve for x, the question said factorize. So in other words, we've shown that x squared minus 4x plus 16, this thing over here, factorizes, move everything to the other side. So it'll become, the one factor will be x minus 2 minus 2 root 3i, and the other factor will be x minus 2 plus 2 root 3i. So that's what x squared minus 4x plus 16 factorized to, x minus 2 minus root 3i, x minus 2 plus 2 root 3i. That's at x squared minus 4x plus 16. So in other words, if I go back to here, to your final answer, okay, x cubed plus 64 is going to factorize to x plus 4 times x squared minus 4x plus 16, which becomes x minus 2 minus 2 root 3i, x minus 2 plus 2 root 3i. Okay, so there's your final answer. Okay, what does x cubed plus 64 factorize to in the complex number system? X plus 4 times x minus 2 minus 2 root 3i, x minus 2 plus 2 root 3i. And remember, in core, that would be your answer over there. Right, a lot more juicy in AP. All right, get that down, press pause, and let's try the next one. Okay, sometimes we're going to have a cubic. Remember with cubics, if you're factorizing cubics, if you can look for groups, it can save you a lot of time. Okay, so we're doing exercise 5, question Q, and it says factorize x cubed minus x squared plus x minus 1. Okay, right. So if we have this one over here, okay, x cubed minus x squared plus x minus 1. If we factorize that, those things can pair up. Remember, when you're pairing up, what has to happen? The brackets have to be the same. So that's going to factorize to x squared, x minus 1. When you times it back out, you get x cubed minus x squared plus x minus 1. Right? So you've got two terms now, that term and that term. What's the common factor between those two terms? X minus 1. What do you have to times x minus 1 by to get back to there? By x squared, and to get back to that term, by 1. You get x minus 1 times x squared, x minus 1 times 1. So it factorizes to x minus 1, x squared plus 1. That'll be your answer in core, end of question. But in AP, you can take it a step further, and it's going to become x minus 1, x plus I, x minus I. Because x plus I times x minus I is going to be x squared. Those will cancel. I times negative I is negative I squared, and I squared is negative 1, so it's negative negative 1, which is 1. So x plus I times x minus I will take you x squared plus 1. Okay, so your final answer, okay, is that x cubed minus x squared plus x minus 1, 5q, factorizes to x minus 1, x plus I, x minus I. Okay, it's been a long video, but then I'm not going to be any other work apart from the video. And the next one, question 6, Peeler. It It says factoring all other cubics in the complex number system. So your method, okay, for anything else, so you're going to always first, with cubics, look for perfect cubes, okay, like we did over here, because it can save a bit of time. So always first thing, look for the methods for perfect cubes. Your next thing you're going to do, okay, is look for grouping, okay, and then if you can't see either of those two, we're going to use the method that we've just been talking about, how we solve cubics, okay, by finding your first factor by trial and error, okay, and then by working backwards, okay, from your solutions to factorize. So, exercise 5, question 5. Factorizing complex numbers, x cubed minus 9x plus 10. So the first thing you're going to do is you're going to let x cubed minus 9x plus 10 be equal to 0. And we may as well, with cubics, let's give it a name. So we're going to have f of x is equal to x cubed minus 9x plus 10 is equal to 0. And your method is what you're first going to do now. Okay, well, you're going to find your first factor by trial and error. The possible solutions for your first solution are the factors of the constant, which in this case is 10. So you're looking at plus or minus 1, plus or minus 2, plus or minus 5, plus minus 10. Okay, for our own sake, it's normally either 1 or 2. So if I put in 1, what you're going to get? You're going to get 1 minus 9 plus 10, which isn't going to work. But if I put in minus 1, what's going to happen? So we're going to have f of minus 1 is equal to minus 1 cubed minus 9 times minus 1 plus 10. So the first part of the sum is just solving the cubic like you've done before. And that's going to be minus 1 plus 9. Hang on, I've done something wrong. Minus 1 cubed is minus 1. Okay, 1 should work actually. F of 1 is going to be 1 cubed, which is 1. Okay, f of minus 1, x cubed minus 1. I've written the question down correctly. X cubed, it's always awkward on videos when no, 1 doesn't work, minus 1 doesn't work. Okay, right, so those don't work. So let's try 2. F of 2 would be equal to 2 cubed minus 9 times 2 plus 10, which is 8 minus 18, sure, plus 10, which is 0. Okay, so f of 2 is equal to 0, which means that therefore x is equal to 2 is a solution. And if x is equal to 2 is a solution, okay, now what's a factor? Good. So x minus 2 is a factor of f, which means what? It means that something else exists such that x minus 2 times some trinomial must be equal to x cubed minus 9x plus 10, which we know is equal to, which we've let be equal to 0. And the first thing we're going to find by inspection, x times what gives you x cubed? X times x squared gives you x cubed. Minus 2 times what is going to give you plus 10. Minus 2 times minus 5 gives you plus 10. And we admit defeat for the middle term, so we get plus kx minus 5. So Hannah, what's the objective now? Good, it's to find k. And to do that, we're going to equate coefficients. Let's look at the x squareds. And x cubed, so I'm going to get kx squared. Where's the other x squared? There, minus 2x squared must be equal to, well, there are no x squareds on the right. Okay, so k minus 2, that's a bit of a nonsense statement, but it works, is equal to 0. So k is equal to 2. Right. So far, I know that x cubed minus 9x plus 10 factorizes to x minus 2. So f of x is equal to, it's just a naming principle, f of x. F of x is going to be equal to x minus 2 times x squared, okay, plus 2x minus 5. So that's our factorizing so far. So in the real number system, in core and metric, which you're going to do this, they ask you to factorize, you'd stop at that point. F of x factorizes to that, because that's a trinomial that can't be factorized by normal methods in the rational number system. Okay, so in core, you would be done at this point. That's your rational factorization. However, we're factorizing in the complex number system. So in the complex number system, what I have to do is I have to go solve that quadratic. So in that quadratic, a is equal to 1, b is equal to 2, c is equal to negative 5. If I use the quadratic formula, x is going to be equal to minus 2 plus minus a square 2 squared minus 4 times 1 times minus 5 all over 2 times 1, which is going to give you x is equal to minus 2 plus minus. This is going to be minus 4 times minus 5, which is 20. Okay, so you're going to get 24. Okay, yep. Okay, 4, let's just double check. Minus 4 times minus 5 is 20 plus 4, 24 all over 2. So we're not going to get a non-real solution, we're going to get an irrational solution. 24 is 4 times 6. So you're going to get x is equal to, so root 24 is equal to 4 times root 6, which is 2 root 6. Okay, so it's going to be minus 2 plus minus 2 root 6 over 2. And that's nice because the 2 disappears. 2 divided by 2 gives you minus 1. 2 divided by 2 is also 1. So you get minus 1 plus minus root 6. Your solutions. X is equal to minus 1 plus minus root 6. So x is equal to minus, or x to minus 1, 6. Which means what are your factors? Move them to the other. This must factorize to x plus 1 minus root 6 is the factor of f, and x plus, move that across, x plus 1, this is this one over here. If x is equal to minus 1 plus root 6 is a solution, then x plus 1 minus root 6 must be a factor of f. And if x is equal to minus 1 minus root 6 is a solution, then it means x plus 1 plus root 6 is another factor of f. Okay, so in other words, the quadratic f of x must factorize to x minus 2, okay, times the product of those two factors, which is x plus 1 minus root 6, x plus 1 plus root 6. And there's your final solution. Okay, x cubed minus 9x plus 10 factorizes to x plus 1 minus root 6, x plus 1 plus root 6. Alright guys, that was a long video, but that's it for today. Okay, just a big thank you. Let's stop sharing so you can meet our assistants. Alright, thank you very much to Hannah. Thank you, Hannah, for coming through in the cold. And thank you very much to Nail. Right, and last but by no means least, wow, thank you very much to Pila. Your assistance is greatly appreciated. Ciao, arrivederci.